Good afternoon. Wonderful animations we've got here. So today I'm going to talk about transforming the service landscape with virtualization. And just one of the things that I believe is that this transformation is profound, and it will change dynamically the network architectures of the future. So really, I think we're at a milestone, inflection point. I was chatting to Don earlier on about that in the industry. So I'm glad you're here, and I'm glad to be part of this and to talk about where we're going. I just stepped through the legal statement, which means you can't shoot me. So let me start with this slide. I've got an 18-year-old daughter, and for a while I've been trying to impress on her that I'm not an ATM machine, And one of the things that we have a group of guys who feel the same where I live. We bought lots of merchandise that we were leaving around in various places as we did this. But one of the problems that I had with the whole equation was the fact that I was told I didn't start early enough. I really should start on the messaging at a much younger age than 18. So I kind of lost out there. But so my daughter has recently, now she's at university, she's determined that actually I have a bit of value as well. So she's now decided that Dad and the ATM, not just the ATM, is probably the best equation of this. And why I mention this is because I wanted to draw a simile with SDN, and I'll explain these terms as we go through. But we have this concept of SDN, and we have this NFV and virtualization, and people have tended to munge these things together and think they're the same. They're actually not the same. SDN is not the same as virtualization. Virtualization isn't the same as an ATM machine. These two things are not the same. But virtualization, that plus the ATM machine, when you put these two things together, they're a real transformational infrastructure, a real transformational architecture that will really change everything in the next few years. And I really want to explain that as we go through this. So I wanted really to start with just a little bit about Juniper's SDN architecture. And SDN, in some respects, was a bit like cloud a few years ago. There was nearly no definition of it. And if you looked up in the sky, you saw a cloud. Something that looks like a boat. No, that looks like a table. Everybody had a different view of this thing. And so in trying to get our grips with SDN in the company, we started to define what we really meant by it. And we defined 6 general principles. And Gartner recently published their definition of SDN and actually adopted a very, very similar format. We talked about the separation of the planes. One of the things in SDN is we're tearing apart the network. We have the forwarding plane of the network, we have the control plane, we have the services and management plane. I'll explain those things. We're splitting those apart. The other thing about SDN is that we're centralizing the intelligence in the infrastructure. And in SDN, we're using techniques like cloud services. We're talking about virtualization. We're talking about things that have been used in the IT industry for years but have not been part of networking. A very key part of our definition of SDN is to create a common platform. This was a common platform that would not only allow Juniper applications, Juniper IP, to be leveraged, but the industry's IP. And you will see the commitment that we've made to that. I think we are really, one of the leaders in the way that we've really approached this whole SDN world and the openness that we've given to that. Next week, we're hosting the NFV Forum, the ETSI NFV. We're very proud to be doing that in Sunnyvale, and to show our commitment to the industry and pulling this together. And we're showing that in everything that we're doing. We want to adopt standards. We want to be open about the way we do things. We're going to apply SDN broadly in the network, not just in the data center. And throughout that, we have a strategy to actually implement that, where we're centralizing our management functions in the business, in our architecture. We're extracting services. We're centralizing the controller. And we're optimizing our hardware to fit with all of this. And one of the other key dynamic areas is changing the way that you actually purchase this stuff. With boxes, you used to just buy them once, and that was it. You got the box, a bit of maintenance, and away you go. With software, there's whole new models of licensing and different ways that you could actually get the right economic value for that and get the right balance with the customer. So we're really changing that as well, because we think that's critical. So just quickly as I go through this, I wanted to talk about the separation of planes. Today, we have the forwarding plane in the network that's responsible for shipping the bits around. We have the control plane that tells the forwarding plane what to do, where to send those bits around. The services plane, the clever services like firewalls and all the other things that we have in networks. And then we have the management that we have to control it. And we're tearing those things apart. Some things we are saying that we're going to distribute, and some things we're saying we're going to centralize. And the model we have today is that we're saying that the forwarding plane, the packet forwarding plane of a network, we're going to continue to have that local. But the control plane we're going to kind of split, because you want to be able to sort of determine where a flow goes, but you don't want to go back to the central controller for every single packet that enters a network. That would be very inefficient. So you end up with this kind of split control plane. And I'll talk more about how we're going to extract services from the network, and been working very extensively with we talked, Don, about the next vision of splitting management planes and all the rest of it. A lot of work going on about what this means to network management in this new world of software. Let me just talk about the most radical thing. Today, Juniper, many people here, many vendors make boxes. We make boxes, that's what we do. Very intelligent boxes with software, hardware, all these things combined that deliver great network value and great functionality. And these are routers, firewalls, all these sorts of things. And what we're going to do is we're going to create software versions of them. We announced recently the purchase of Control Networks. This is our platform for SDN. And on that platform, we're able to run a whole load of software-based applications that are representing network functions. We have another very important concept in SDN, and that's the concept of a service chain. A service chain is where you can take a number of unique network functions and connect them together to create a service context. So you would have for a customer, for example, here we've got DDoS mitigation, load balancer, stateful firewall, deep packet inspection, a number of things that would form a service. And on the fly, we can create that chain of services and connect those into the network in a way that they can deliver a customer experience end-to-end for the customer, all on the fly, dynamically and scalable. It's a whole new model for the industry. So I wanted to show this slide, really to just show our commitment to openness. You'll see at the end slide a slide that shows our partners. When we announced recently the Open Contrail and the work that we were doing, we surprised everybody by announcing Checkpoint could run on our platform, and we have one of the leading firewalls that competes with them. We are really working in a whole new way, and you can see this commitment. We call that, you can pick up, we believe that our services should stand on their merits. We believe we've got best-in-class services, and we'll convince you as our customers that we have. But we also want to work with the industry and to give choice. So we're working with Akamai, we're working with Sonos, we're working with a number of people that you'll see on the list, Riverbed, Silver Peak, lots of people, and we're increasing our ecosystem that will work on our platform and provide the customer with choice in terms of the applications that can run on our platform. I mentioned the new licensing model, very, very important side to this, moving from the traditional model of upfront CapEx to more elastic models, even transferable licenses. Real radical thinking in the way that we've been working, and lifetime software assurance and all of this. So we're talking about that. But just wanted to move on very, very quickly, as we've got a short time slot, to talk about network virtualization and the way that the industry has been moving. And really, when you look at SDN, you would really say that its real genesis was really in the data center, I believe. Traditionally, in the data center today, we have the concepts of VLANs. We have a physical infrastructure, and you can see these different colored networks that I've got on this diagram here. And today, if you wanted to provision these VLANs, it's a very, very mechanical process. You go in and you configure them. There are limitations on the number of VLANs per port, 4,096 on a port. If you make one misconfiguration, you can connect one customer to another customer. It's got relatively low scalability. It's fragile because it can be misconfigured. At any point in the network, you're doing manual configurations of the next hop. It's a bit of a nightmare. But a lot of data centers are based on VLANs, and that's the technology that we've had for a long time. Of course, people like Google and other people, originally, of course, this all started in Stanford with our Clean Slate program, looked at how they could change this, how they could bring dynamic capabilities to network infrastructures, and began by connecting PCs to Ethernet switches and looking at new ways with the students of actually creating networks. And that led on to OpenFlow and OpenFlow controllers. And you see Google, other people building real data centers with this sort of technology. I think you were talking about last week on God knows how many people in Germany working on OpenFlow, and it's a big ecosystem now. And OpenFlow does, in fact, have some disadvantages. In Juniper, we believe that this was the first stage of evolution of SDN. We're going to see many different stages of evolution, and we think we need to move on to another stage, although we still support this one. And with OpenFlow, there are some restrictions. The first packet in OpenFlow has to be sent to the controller, so the controller can inspect it and decide where things go. Well, that's a really high latency kind of design. I was looking recently, we look at 50 milliseconds for networks that quite often we configure when something goes wrong. And they said, well, we've got this OpenFlow implementation, 6 seconds reconfiguration time. I mean, 6 seconds in a real network, I don't think so. So there's a number of things. There are some limitations with this. It's still a very good technology for certain applications. We believe it's got low scalability for a number of reasons. There are new failure modes. But one of the fundamental things about OpenFlow is that the switch has to understand the protocol. So if you've got a switch that understands OpenFlow 1.0 and you want to move to 1.3, you can't move to 1.3 if that switch doesn't support 1.3. And if the manufacturer says, I'm sorry, on that particular switch, we're never going to build 1.3, you are finished. You cannot support 1.3, right? So it's a forklift upgrade type of thing with the switches. And that's also a limitation because people want to find a way to implement SDN on what they've got, not just on what they're going to buy. Right? So we in Juniper have been looking at the next generation. By the way, we're going to support 1.3 on our hardware. We were some of the first people to support 1.0, so we're still very committed to OpenFlow. Don't get me wrong in what I'm saying. But as we move forward, we want to really find the next horizon of SDN architecture. And so we're looking at what we call proactive overlays, where we have a controller that proactively programs the virtual overlay network that runs across the infrastructure. And now we've extracted the virtual overlay to run at one stage further out from the network. We don't actually talk to the switches. We use protocols that can go through the switches. We now talk to the servers. We build the overlay from the server to server. We insert into the servers a plugin that plugs into the hypervisor on the server. Today it's KVM, that's where architecture is. We're moving on to support other hypervisors as well. And this is a virtual router which will configure connectivity on that server between different virtual machines. Between those different servers, you'll see these blue lines, we create virtual connections. These are connections that can run on MPLS GRE tunnels or they can run on VXLAN, and they'll pass transparently because these are protocols that network switches understand. This overlay architecture can run across anything. Of course, it's going to run even better in the future when the network and this overlay can connect together in a real way, and they will quite soon. And there are a whole load of new protocols that you need in this infrastructure. In order to configure those routers, we're using things like XMPP, which is a standard. It's also called Jabber. It's a messaging standard. We're using NetConf as the network management, which we use today on the physical boxes. So we're using BGP, which is the protocol of the internet. And one important point to take is in a network, you can't have a single point of failure in a really professional telco infrastructure. So what we're doing is we're making these controllers communicate with BGP and maintain state. So if you lose one of the controllers, you don't lose the whole network, right? This is way beyond. The OpenFlow is trying to address that, but that really is way beyond what OpenFlow can do. And of course, BGP as the thought about an internal network and an external network, and we've thought about all of that. Right? So there's a whole lot more in this infrastructure. But I wanted to talk about some use cases now, because we talk about all this SDN stuff. But it's great. Oh, wonderful technology. What does it mean? Yeah? It's meaningful when we can deliver a service to the customer. Yeah? A service that the telco, the operator, can monetize in some way. What does it really mean? So I want to talk about some real use cases. Well, the idea of building these dynamic service chains offers the ability to offer a whole load of new services to the customer. Services that span both the mobile edge, the broadband edge, and the business edge of a network. And some of the foundation services that we're looking to actually bring to market are things like virtual CPE. I'll talk about that in a minute and what that means, but it could change the whole architecture of managed services today. And I'll talk a little bit more as we go through very, very quickly about that. We're talking about the ability to have self-service enterprise services available through a portal on demand in the network. Things like UTM, threat management, things like firewalls, things like DPI, things like WAN optimization. These are all things that in the future a customer could just switch on an instant and have those things available. Could even scale them in the network at an instant anywhere. It's a whole new model that brings flexibility and new revenue streams to the service provider and to the customer. This new class of service means that we can take things like VPNs that have been around for a long time, of course, and Juniper is pretty expert at those things and MPLS, and we can connect those things into tenant virtual PCs that exist in the cloud. And we can do that in a way as to maintain a quality of service or different levels of quality of service into those infrastructures. And we can do that dynamically on the fly. You want a server? Boom. You want a server between 2 and 4? Boom. You want it with this level of quality of service? Boom. You want to know that the end-to-end quality of service has been maintained over that period? Yes, you can as well. And this is a whole new world that allows so many different services to be created. And one of the models, and I'll talk a little bit as I begin to end this presentation, that is very interesting to a number of service providers that I've talked to, is the whole model of becoming a cloud aggregator. And in this model, they talk about this model where they've actually got these tenant PCs in their network, but also they talk about connecting to Google and to people like Salesforce.com and to Microsoft, and the telco becoming an aggregator for those services. So let me just talk about that a little bit. Excuse me. I go to a lot of service providers around the world. It's one of the great pleasures that I have to talk to them and ask them about their innovation and the things that they do. And they say a number of things. One service provider in the Nordics talked to me recently. They're putting big links into Microsoft, into Azure. And what they're going to do is offer Office 365 to their customers on demand through their portal. And they can say, what about security? Well, it runs on our pipe all the way there. It's actually on our pipe. It's in our infrastructure. Right? They have virtual connections into Salesforce.com. They say, yeah, we can do that. We can provide that. And there are 3 things that the service provider talks about that really allows them to add great value to cloud services. So let me talk about those 3 things, because they near enough all say the same thing. The first thing they say is we can offer an application SLA. Because we've got a network, right, we can offer end-to-end. We can guarantee from the server, and they're building the OSS systems to begin to do that. We can guarantee from the server all the way to the end user the performance, and we can show you who delivered it. I mentioned that one. The second thing is a little bit more difficult perhaps to understand, but they call this thing service wrap, right? Service wrap. We can give you one bill. We can give you one point of contact. So you don't get into a situation where the thing isn't working and you go, is it oh no, our cloud is working wonderful. And you ring the network provider, it says, it's not our network's fine. You're like in the middle of it. You don't want that, right? You don't want to have a bill to every single cloud application you're going to get in the future. You want a different place to ring. You want to, hang on, Salesforce.com, I ring this number, Microsoft, I ring this number, I've got 20 different applications. How do I deal with that, right? So all of that thing is another thing that the service provider can provide, which is very important. The final thing, which is really important, I can mention to you that Swisscom called it Swissness. I said, what is Swissness? They said, it's very simple. Swissness means your data stays in Switzerland. I thought, okay, I kind of understand that. But one of the things you have to realize is that when you move applications to the cloud, well, you don't just move the application, you move the data. The data is your crown jewels. We're using Salesforce.com in the cloud in Juniper. That's our customer database. That's our deals. That's pretty important to us, yeah? Right? So we put that sort of information in the cloud. We've got to make sure that it's really safe. And the other thing we've got to make sure is things about compliance. Compliance currently, I looked at IDC recently. Moving applications to the cloud used to be security was the number one thing that CIOs were worried about. You know what it is now? Compliance. Security is number 2. What does it mean? Well, I move my customer data to the cloud, right? And where is it, right? How am I looking after it? Who's looking after it, right? I go to my board because it's been lost. And my company in the EU can be fined nearly 3% of revenue for the loss of certain types of customer data. I mean, my wife uses Dropbox. She loves Dropbox. I use Dropbox. She said, I get it in Dropbox, right? I said, do you know where this Dropbox is? No idea. Can you imagine going to your board and saying, I put all the accounts and my customer details in Dropbox? Great. What sort of a data retention policy do they have? What sort of physical security? Where is it? I don't know. I don't think you'd survive very long. Right? So it just shows you the way this world is going. I mentioned one of the most interesting use cases that I think will be one of the early ones that's also being talked about extensively in the NFV forum. Everywhere I go, people are talking about it. And that's the idea of cloud-based CPE, both for the consumer market and for the business marketplace. Today, we have physical CPE. I mean, I looked recently at the cost of a typical enterprise CPE. It was 1,700 euros, roughly, you know. I looked at the value chain around that and the inflexibility of that. And when you actually install it, you have to send an engineer down to the site. The cost of acquisition is very high. If you could just have a simple Ethernet box that was delivered, and all of the services could be in the network, what sort of flexibility could you provide? What sort of cost reduction could you provide in that kind of an infrastructure? The customer self-install, plug the box in, away you go. New services on the fly, all the things we talked about, threat management, new ideas, all sorts of things that the customer might want. You can see a list of some of the types of services. I won't go through those. I just want to give you the principle. But the idea of having a self-service portal that you can go into and you can provision all these things, let me tell you that as Juniper, 2 years ago, we started delivering virtual CPE on our architecture. We're now moving on to another kind of an architecture using Contrail to deliver this. We've got 2 or 3 customers already working on it. There's a whole load of new things in this space that we're leading with. And one of the things is the development of the portal that can enable this to all work. It's a really interesting new development. So just to finish off, I wanted to mention the announcement that we made this month on the 16th. We announced, I think it's a real statement of openness and our commitment to the industry. I hope you agree when I explain it, but we announced the open sourcing of our whole SDN platform, everything. People were a bit shocked, everything. The virtual router, the controller, everything is now published on this site. Of course, we will have a model where there will be a commercial version of this, which will be guaranteed and will support. But we want to take advantages of the innovation of the Internet and to make this technology available to everybody. We announced a deal of partnerships that shocked the industry in some respects, partnerships with people you would think would be our competitors, because we wanted to show that we really think this needs to be inclusive architecture. Our commitment to ETSI NFV is another example of that. We also announced our work that we're doing with IBM. I was just recently in the Goad, I just got back from there, working on some transformational architecture about OSS. OSS has got to fundamentally change. I've been in the TM forum for 20 years. I can tell you the changes are profound to the way that OSS has got to work in this new world in automation. Just imagine the world where you used to have a network management center with boxes on the screen. It had about 20 countries, 1 box per screen. You know, Manchester, London, Paris, Amsterdam, all these different places where you had a node. It was easy to look at. And in NFV, there could be thousands, even millions of instances of something. How do you put that on a screen? How do you configure each one of those with a CLI? Forget it, right? There's a whole new world out there. And you can see the Open Contrail website. We'll publish these slides. You can go on it. You can download the source code of our SDN architecture today. It's available for you. We also announced all of these partnerships as a commitment to the industry. You'll see Checkpoint on there as well. And you'll see many more people added to this list over the next few months. We're working with a lot of people. One of the key areas I'd point out in my last slide is really just to say that Guavus is an important partner here. We're looking at analytics. Analytics is a very important part of this. New techniques for the analysis of data, big data, are very important. Big data represents an enormous amount of information. You know, an enormous amount of information is not helpful. It's very confusing. What you want is knowledge. So how do you extract knowledge from information? Techniques like MapReduce, all these things, and we want to use best-in-class products to actually take us there. So, just to thank you for your time. I want to leave you with the message that we're working with the industry in a very open way of innovation. And if there's any time, I don't know, we can maybe take a question or so, I don't know. Thank you.